Hello guys, welcome to Makaut CSE and also welcome to our video on mobile computing in computer science. Today we will explore the key topics such as the personal communication services, general packet radio services, data communication, the wireless application protocol. Okay, so we will delve into the wireless local loops, 3G mobile services and global satellite system in the mobile computing subject. Through this journey, you will understand the technologies that power our mobile world. So join us as we uncover the past, present and the future of mobile computing. Let's get started. So at first we need to learn about the Introduction to Personal Communication Services or PCS. The PCS encompass a range of wireless communication capabilities designed to provide the seamless voice, data and multimedia services to users on the go. PCS is integral to modern mobile computing, enabling the ubiquitous connectivity and fostering enhanced personal and professional communication. The service category is essential as it supports the mobile telephony, the text messaging, internet browsing and various application criteria in today's fast-paced world. The importance of PCS lies in its ability to facilitate the constant connectivity, supporting both the personal and business needs, thus enhancing productivity and convenience is in everyday life. So the historical development and evolution of PCS. The evolution of PCS is marked by significant technological advancement and regulatory milestones. The concept originated in the late 1980s and early 1990s when the Federal Communication Commission (FCC) in the United States allocated a spectrum specifically for PCS. This move catalyzed the development of digital cellular technologies, transitioning from analog system to digital networks, which provided the higher capacity and better quality. Over the decades, PCS has evolved from simple voice communication to sophisticated multimedia services driven by advancement in mobile computing and wireless technology. The advent of 3G, 4G and now 5G networks has significantly expanded the capabilities of PCS, offering the faster data speeds, lower latency and greater reliability. Okay. So the components, the PCS comprises several key elements that work together to deliver its services. Handsets, commonly known as mobile phones, are the most visible component allowing users to access the PCS services. Base stations or cell towers from the backbone of PCS networks, facilitating the wireless communication between handsets and the broader telecommunication infrastructure. The networks themselves consisting of a series of interconnected cell towers, switching stations and data centers ensure the continuous and seamless services as users move from one location to another. One of the fundamental differences between PCS and other communication services such as traditional landline telephone lies in its mobility and digital nature, enabling the real-time location-independent communication. Now application. In daily life, PCS is used in numerous ways, underpinning many activities and services. Voice calls remain a primary application, allowing individuals to communicate effortlessly over long distances. Text messaging provide a quick and convenient means of communication, while the internet browsing and email capabilities keep users connected to the digital world. PCS also supports a myriad of mobile applications from social media and entertainment to navigation and financial services. In the context of mobile computing, PCS enables a real-time collaboration through video conferencing, access to cloud-based application and remote work capabilities, significantly enhancing their productivity and flexibility. So in summary, the personal communication services are a cornerstone of mobile computing, offering the essential communication capabilities that have transformed how we live and work. Its continuous evolution and integration with advanced technologies ensures that the PCS will remain vital in supporting our increasingly connected world. So now it is time to discuss about the General Packet Radio Services or GPRS. So General Packet Radio Services is a packet switch data service that enable 2G and 3G cellular networks by enabling the transmission of data in a more efficient and scalable manner. Introduced in late 1990s, the GPRS marked a significant step forward in mobile communication, providing the continuous connectivity and facilitating the various data services such as internet browsing, multimedia messaging, and email on mobile devices. It plays a crucial role in mobile communication by bridging the gap between the traditional circuit-switched voice networks and modern high-speed data services, thus paving the way for the development of modern advanced mobile technologies. So, Historical context and development. The development of GPRS began in the mid-1990s as mobile operators sought to enhance the capabilities of their existing GSM, Global System for Mobile Communication networks, officially standardized by the European Telecommunication Standard Institute (ETSI) in 1997. GPRS was designed to provide the packet switch data transmission, which allow multiple users to share the same transmission channels efficiently. The deployment of GPRS started around 2000, and it quickly became a popular solution for mobile internet access, setting the stage for the widespread adoption of mobile data services that followed with 3G and 4G technologies. So some technical details, like GPRS works by breaking down the data into packets and transmitting them over the shared network channels. Unlike traditional circuit switch networks that dedicate a specific path for each call or data session, this packet switched approach allows for more efficient use of network resources, as multiple users can share the same channels simultaneously. So the key components and architecture of GPRS networks, it includes the mobile station, base station subsystem, service serving GPRS support node, gateway GPRS support node, GPRS tunneling protocol. Okay, so these are the components. So mobile station, these are the mobile devices used by end users to access the GPRS services. Base station subsystem means comprising base transceiver station (BTS) and base station controller (BSC). The BSS handles the radio communication with mobile station. So serving the GPRS support node like SGSN is responsible for delivering the data packets and to and from mobile station within its service area, handling the tasks such as mobility management, authentication and session management. Gateway GPRS support node. The GGSN act as an interface between the GPRS network and external packet data networks such as internet, managing IP addresses allocation and routing of data packets. GPRS tunneling protocol is used to encapsulate and route the data packets between the SGSN and GGSN, ensuring the proper delivery across the network. So, in conclusion, GPRS represents a critical advancement in the mobile communication, enabling the more efficient data transmission and continuous connectivity. While it has certain limitations, its introduction has laid the foundation for the development of more advanced mobile data services and technologies. So now it is time to discuss about the data communication in mobile computing. Data communication refers to exchange the data between the devices through a transmission medium. In mobile computing, data communication is the backbone of enabling the transfer of information across the various platforms and devices. It encompasses all the forms of digital data exchange, from sending emails and browsing the internet to streaming voices and using mobile apps. The significance of data communication in mobile computing lies in its ability to facilitate the seamless connectivity, enabling the real-time communication, access to information and various services that enhance the productivity and convenience for user on the move. So types of data communication like wired data communication, wireless data communication. Data communication at first wired. This involves the use of physical cables and connectors to establish a communication between the devices. Common examples include the Ethernet cable, USB connection, fiber optics. Okay, so wired communication is typically known for its reliability, stability, and high data transfer speeds. So wireless data communication. This involves the transmission of data without physical connectors using electromagnetic waves. The wireless communication methods include the Wi-Fi, Bluetooth, cellular networks such as 4G, 5G, okay, and the satellite communication. The wireless communication is favored for its flexibility, mobility, and the convenience, making it essential in mobile computing. So protocols and standards. Data communication relies on various protocols and standards to ensure the proper data exchange and the interoperability between the devices and networks. Some common data communication protocols at first TCP/IP, Transmission Control Protocol and Internet Protocol. The fundamental suite of protocols governing the internet communication. TCP ensures the reliable data transmission while IP handles addressing and routing. UDP or User Datagram Protocol, a simpler connectionless protocol. used for application where speed is crucial and error correction can be handled by the application itself, such as in live stream or online gaming. HTTPS Hypertext Transfer Protocol secure. This protocol is used for transferring the web pages over the internet, with HTTPS providing a secure the encrypted connection. Okay, so standards and regulation like IEEE, Institute of Electrical and Electronics Engineers. It develops and maintains a standard for various communication technologies, including the Ethernet, IEEE 802.3 and Wi-Fi, IEEE 802.11. 3GPP, third generation partnership project, responsible for setting the standard for mobile telephony, including 3G, 4G and 5G. IETF, Internet Engineering Task Force, develops and promotes voluntary internet standards, particularly those related to TCP/IP. So applications. Data communication is pivotal in enabling a wide range of real-world applications in mobile devices, contributing to the functionality and utility of mobile computing. At first, email. Okay, so allows users to send and receive the messages and attachments over the internet, facilitated by protocols such as SMTP, Simple Mail Transfer Protocol, IMAP, Internet Message Access Protocol, and POP3, Post Office Protocol. Internet browsing. It also enables users to access the web pages, search for information, and interact with online content via web browsers, relying on HTTP and HTTPS protocol. Social media. Platforms like Facebook, Twitter, Instagram rely on the data communication to allow users to interact, share the content, and stay connected. Streaming services. Services like Netflix, Spotify, and YouTube use data communication protocols to deliver the audio and video content to mobile devices in real time. Mobile applications. Various apps from navigation tools like Google Maps to messaging apps like WhatsApp depend on efficient data communication to provide the real-time information and connectivity. Say examples like email, internet browsing, video streaming. Okay, so in summary, the data communication is crucial for aspect of mobile computing, enabling the various applications and services that enhance the connectivity, the information access, and the user experience. Through a combination of wired and wireless methods, protocols, and standards, data communication facilitates the seamless interaction between the devices and networks, supporting the diverse needs of modern mobile users. Okay, so now it is time to discuss about the wireless application protocol. The overview. The wireless application protocol is a standardized protocol that enables the mobile devices to access the internet content and services, developed to address the limitation of early mobile devices such as small screens and limited processing power. The WAP provides a framework for delivering the web-based content and applications in a simplified, efficient manner. Its primary purpose is to facilitate the mobile internet access, allowing users to browse websites and check mails and perform other online activities using their mobile phones. The historical development and evolution of WAP. WAP is introduced in the late 1990s by the WAP Forum, an industry group formed by the major telecommunication companies, including the Ericsson, Motorola, Nokia, and Anomat Planet. The first version of WAP 1.0 was released in 1998. It was designed to work with existing mobile networks, primarily 2G, and provide a way to deliver the basic web content to mobile devices. WAP 2.0, released in 2002, introduced the significant improvements, including the support for mobile, more advanced web technologies like XHTML and TCP/IP. Despite its initial promise, WAP faced criticism for its slow speeds and limited user experience, and its use declined with the advent of more advanced mobile browsers and faster networks. So some technical details like WAP architecture consists of several key components that work together to enable the mobile internet access, like mobile device like client, the user's mobile phone or PDA equipped with a WAP browser to request and display content. WAP gateway or proxy acts as an intermediary between the mobile device and the internet. It translates the WAP request into the standardized HTTP request and converts the web content into a format suitable for mobile devices. Web server hosts the content and applications that the user accesses via a WAP browser. Content format like WML, wireless markup language, was used in WAP 1.x, while the WAP 2.0 adopted XHTML MP, like XHTML mobile profile, allowing for more sophisticated content. So how WAP enables the mobile internet access? WAP enables the mobile internet access by providing a lightweight protocol stack designed for mobile networks. When a user requests a web page via a WAP browser, the following processes occurs, like first request, translation, response, conversion and display. Okay, so applications like browsing, email, news and information services and mobile banking. So impact on WAP on mobile communication and its legacy, like WAP had a significant impact on mobile communication by pioneering the mobile internet access. It's demonstrated the potential of mobile devices and tools for online communication and information accessing. Okay, so in conclusion, so WAP was a pioneering effort to bring the internet access to mobile devices. Despite its challenges, WAP played a crucial role in the early days of mobile internet, influencing the development of subsequent mobile technologies and standards. So the wireless local loop, the overview. At first, the definition and significance of wireless local loop, WLL. Wireless local loop refers to a system that connects the subscribers to the public switch telephone network, PSTN, using the wireless technology as an alternative to traditional copper wires. WLL is significant because it provides an efficient and cost-effective solution for delivering the telecommunication services, particularly in areas where laying physical cables is impractical or too expensive. This technology plays a crucial role in extending the telecommunication coverage to the rural and remote regions, bridging the digital divide and enhancing the last mile connectivity. Historical context and development of WLL. The concept of WLL emerged in the early 1990s as telecommunication providers sought alternatives to traditional wired infrastructure to expand their service reach more rapidly and cost effectively. The development of WLL was driven by the advancement in wireless communication technologies and the increasing demand for telephony services in the undeserved areas. Over the years, WLL has evolved, incorporating more sophisticated wireless technologies to improve the performance, the reliability, and the capacity. The introduction of digital wireless standards and the proliferation of mobile networks have further enhanced the WLL's capability and adoption. Technical details: how WLL works and its components. WLL systems operate by using the wireless communication to connect the subscribers' premises to a central base station, which then links to a broader telecommunication network. The key components like base station, the central node that communicates with the subscriber units with its coverage area. It serves as the interface between the wireless local loop and the core telecommunication network. Subscriber unit, the device installed at the subscriber premises that communicates with the base station. It can be an outdoor antenna connected to an indoor unit or an integrated device. Switching center, manage the call processing and routing functions connecting the WLL system to the PSTN or other networks. Okay, so the types of WLL technology like fixed, nomadic and mobile WLL. Fixed WLL means provides a fixed wireless connection between the subscriber and the base station. It is intended for stationary uses, typically in residential or business premises. Nomadic WLL means the offers the limited mobility within a defined area, allowing subscriber to move their equipment within the coverage zone for the base station. And mobile WLL combines the features of mobile networks with WLL, enabling the full mobility for subscriber similar to cellular services. This type leverages the mobile network standards like GSM or CDMA. Okay, so advantage and challenges like cost effective and deployment, okay, and the rapid installation, flexibility and scalability and accessibility in remote areas. So in conclusion, WLL is a pivotal technology for extending the telecommunication services, particularly in areas where the traditional wired infrastructure is impractical. Its development has been driven by the need for cost-effective and rapid deployment of telephony services. Despite its challenges, the WLL remains a valuable solution for improving the last mile connectivity and bridging the digital divide, especially in rural and remote regions. So now it is time to discuss about the 3G mobile services. So introduction. The third generation mobile technology represents a significant advancement in the mobile communication, offering the higher data transfer rates, improved the voice quality, and the enhanced multimedia capabilities compared to its predecessor. 3G technology enabled a broader range of services, including the mobile internet, video calling, and mobile TV, transforming the mobile phones into versatile communication devices. Its primary role was to provide the faster and more reliable mobile internet access, facilitating the growth of mobile applications and services that are in general integral to modern life. So evolution of 2G to 3G and key milestones, like the transition from the 2G to 3G marked a shift from the basic voice and text services to more sophisticated data-centric services. The key milestone in this evolution include the 2G, 3G, and launch of 3G services and 3G standards. At first 2G. It introduced in the early 1990s. 2G technologies like GSM, Global System for Mobile Communications, and CDMA, Code Division Multiple Access, focused on the digital voice and the basic SMS services, providing the limited data capabilities. The 3G development. The International Telecommunication Union (ITU) set a standard for 3G with the IMT 200 International Mobile Telecommunication 2000 initiative, aiming for the higher data speeds and improved network capacity. So the launch of 3G services. The first commercial 3G networks were launched in Japan by NTT Docomo in 2001, followed by the rollouts in Europe and the United States. 3G standards. WCDMA, like Wideband Code Division Multiple Access, and CDMA 2000 become the primary standard for 3G, offering the peak data rates of up to 2 Mbps for stationary users. Okay, so technical details like key features and architecture of 3G networks, like categorized several key features like high speed data transmission, the improved spectral efficiency, the enhanced network capacity, and quality of services. Okay, quality of services actually including the services including the voice, video, and data. 3G architecture, like the user equipment UE, the radio access network RAN, the core network, and the RAN comprising the node, base station, and radio network controllers. Okay, user equipment means the mobile devices like smartphone and tablets equipped with 3G capabilities. The core network like consists of circuit switched domain for voice services and the packet switch domain for data services, managing the call routing and mobility and data transmission. Okay, so how 3G improves the data speed and connectivity? By using the WCDMA and CDMA 2000, HSPA like high speed packet access, adaptive modulation and coding, and carrier aggregation. So application including the video calling, mobile internet, streaming media, mobile applications. Okay, so impact of 3G in mobile industry and society, like industry transformation, economic impact, social connectivity, and the foundation for future technologies like 4G and 5G. In summary, 3G mobile services marked a significant leap in mobile communication, providing the foundation for modern mobile internet and multimedia services. Its advancement in data speed, network capacity, and service quality have had a profound impact on the mobile industry and society, enabling the wide range of applications and setting the stage for the future technological developments. So now it is time to discuss about the global satellite system and their purposes. Global satellite system are network for satellites that provides a wide range of services, including the communication, navigation, and broadcasting to users across the globe. These systems play a crucial role in modern society by enabling the global connectivity, precise location tracking, and the dissemination of information. The primary purpose of global satellite systems is to overcome the limitation of terrestrial infrastructure, providing the coverage in remote and inaccessible areas, and supporting applications that require the high reliability and global reach. So historical development and key milestones. The development of global satellite system began in the mid-20th century, driven by advances in space technology and the increasing demand for the reliable communication and navigation services. So key milestones in development of this system include the Sputnik 1, 1957, launched by Soviet Union. Sputnik 1 was the first artificial satellite, marking the beginning of the space age. Telstar 1, 1962, the first active communication satellite capable by capable of relaying the television, telephone and data signals, launched by AT&T Laboratory and NASA. Intelsat 1, 1965, also known as the early bird. This was the first commercial geostationary communication satellite providing the transatlantic television and telephone services. Global Positioning System 1978 to 1995, developed by the US Department of Defense. GPS became the fully operational in 1995, providing the global navigation and timing services. Iridium 1998, a consultation of low Earth orbit (LEO) satellites, providing the global voice and data communication. So technical details mean how satellite communication works. Satellite communication involves the transmission of signals from the Earth-based transmitter to a satellite, which then relay the signal back to a receiver on the ground. Okay, so the process typically includes the following steps like uplink, satellite transponder, downlink. Uplink means the signal is transmitted from Earth station like ground station to a satellite. Satellite transponder means the satellite receives the uplink signal and amplifies it and change its frequency and transmit it back to Earth. Downlink means the signal received by the another Earth station or directly by user equipment such as satellite phones or GPS receivers. So key components of global satellite system like satellites, okay, positioned in various orbits: geostationary, medium Earth orbit or low Earth orbit, depending on the intended application and coverage area. Geostationary satellite, medium Earth orbit satellite and low Earth orbit satellites. So ground stations facilitate the equipped with antennas and communication equipment to transmit and receive the signals from satellites. They serve the interface between the satellite network and the terrestrial network. User equipment like devices like satellite phones, GPS receivers and satellite TV dishes that enable the end users to access the satellite services. Application like navigation, communication and broadcasting. Okay, DTH is application like satellites deliver television and radio broadcast to large audiences, including the direct to home services and satellite radio. Impact of satellite technology on global communication and connectivity, like global coverage, disaster recovery, economic development and scientific research. So in conclusion, the global satellite system are essential for components of modern communication and navigation infrastructure. Their development has significantly expanded global connectivity, enable the precision location tracking and facilitating the dissemination of information on global scale. Okay, so at the end of the video, so as we conclude our exploration of mobile computing, we hope this journey has provided valuable insights into the dynamic landscape of wireless communication. From the personal communication service to global satellite systems, we have delved into the foundation and innovation shaping our digital world. Remember, the evolution of mobile telephony continues to redefine how we connect and interact. Stay curious, stay connected, and embrace the possibilities of tomorrow. Thank you for joining us this enlightening journey. Goodbye for now, and until next time, keep exploring the wonders of mobile computing. Okay, thanks for watching also, and like, share and also subscribe our channel for more videos. Okay, so goodbye.